In this video, I will explain the fuzzy variable used in my project. The system has two inputs, which are specificity score, evidence reliability, and one output variable, which is final decision confidence. These variables help to determine how confident the system is that a video is manipulated. So for this graph, show the fuzzy membership function for specificity score. The domain range from 0 to 10, where higher values mean more conditions are satisfied. The low specificity, which is 0013, represents the case where only one condition is met. Medium specificity 1357 represents two conditions, and high specificity 571010 represents three or more conditions. The overlapping regions allow to score to partially belong to multiple categories, which help the system handle uncertainty smoothly. So for the second graph, which is the evidence reliability with a domain from 0 to 10, where higher values mean more trustworthy evidence. For the low reliability, which is 0024, correspond to tier 3 evidence. Medium reliability 2468, represent tier 2 evidence, and high reliability, which is 681010, represent tier 1 evidence. The overlap between this membership function allows gradual transitions instead of sudden change in reliability. So, for the output graph, which is the final decision confidence, with values from 0 to 10, where higher values indicate the stronger confidence. So, weak confidence, which is 0024, means the system is unsure. And for the moderate confidence, 24610, represent the borderline cases. And strong confidence, 681010, indicates a high confidence in manipulation detection. So in conclusion, these fuzzy variables and overlapping membership functions allow the system to handle uncertainty and produce a more realistic confidence level when classifying a video manipulation.
Now, let's look at how we constructed our rule base, which we refined them directly from conflict resolution strategies we developed in our project PBL2. In PBL2, we identified two major conflict scenarios. First is multiple manipulation type, where we use specificity ordering to prioritize complex rules with more conditions. Next, voice versus audio conflicts, where we use an evident reliability hierarchy. However, Prism logic forces us to make binary choices, choosing one rule and discarding the other. In this fuzzy system, we solve this by converting those binary priorities into continuous variable specificity score and evidence reliability. First rule state if specificity score is high and evidence reliability is high, then confidence is high. Next, we have if specificity is medium and reliability is medium, then confidence is medium. Finally, if specificity is low and reliability is low, then confidence is low.
So for this part, I will show you a live fuzzy inference system that evaluates decision confidence based on two inputs. This is a specific score and evidence reliability. So I will run the system live and explain which rules are firing and the range. Also present the crisp output for the three keys. Okay, this system has two inputs. Specific score ranging 0 to 10 with low, medium, and high membership functions. Evidence reliability also 0 to 10 and also with low, medium, and high memberships. So for the output, we get a decision confidence and ranging to 0 to 10 and also with low and medium and high. So now we go to case 1. So for the specific score, we got 8 and evidence reliability, we got 9. So we got this graph. Specific 8 is mostly high and reliability 9 is mostly high. So plus 1 is high and high. So we got a high confidence. So for the firing range, we got a 0.8 because of the minimum of the two memberships. So this meaning this rule contribute 80% for the output, and the other rules do not fire because the output membership is weak. So we go to this case 2. So specific score we got 6 and evidence reliability we got 7. So here the diagram we got. So for the rules fires, we got a medium and medium. So we got a medium confidences. So the fire range we got a 0.6. Other overlapping rules like rules 5 and rules 6 may partially fire depending on the membership, but rule 2 has the strongest influence. So now we go to test case 3. For the specific score we got 2 And for the reliability, we got 3. So here the diagram we got. So for the specific 2 and reliability 3 is mostly low, and rule 3, low and low, go to low confidence, but with a low firing strength equals to 0.2. This means the rule contribute only 20% to the final decision confidence. Other rules, such as rule 7, low and medium, go to medium confidence, may partially contribute depend on the membership overlap. For case 1, our input specific score is 8. Evidence reliability is 9. Both belong to the high category with membership value 0.8 and 0.9. Our risk fire with 0.8. We clip the higher coefficient triangle at the 0.8. So for COG, we calculate area of the triangle and area of rectangle. Multiply each area by its centroid, sum them, and divide by total area. CLJ equals to 8.28. For weekend, since only one roost fire, we multiply by fire strength by the output value and divide by fire strength, and we got the 10. For means of maxima, we take all x value at maximum membership and average them, and we got 9.5. This shows how different differentiation methods slightly varies, but all represent a strong confidence output.
For the interpretation, domain, and justification part, I will start with the first test case. As you can see here, the specificity score is 8 and the evidence reliability is 9, which both input are high. So because of that, the system produced a crisp value of around 7.92, which indicates strong confidence. In a cyber-related decision system, this means evidence is clear and reliable, so the system can support taking action with a lower risk of making a wrong decision. Moving on to test case number 2, with a specificity score of 5 and evidence reliability of 6, where both input are considered medium. It produced a crisp value of around 4.8, which falls under moderate or medium confidence. This shows that the evidence is somewhat reliable, but not strong enough to be fully trusted. So with this result, it usually requires further checking before we can make final decision. For the last test case, where the specificity score is 2 and the evidence reliability is 3, both input are low, which gives a crisp value of 1.56 that represents weak confidence. So, acting on this kind of weak and unreliable evidence could lead to false alerts or incorrect conclusions. So, the system correctly avoids recommending immediate actions. So, in conclusion, for this project, the center of gravity defuzzification method is the most suitable to use. This is because it takes into account the overall shape of the aggregated membership function, rather than only looking at the highest membership value. By using the center of gravity method, the confidence output changes more smoothly, which helps avoid sudden jumps in the final decision. When compared to the weighted mean or mean of maxima, center of gravity gives a more balanced result, making it more suitable for handling uncertainty in the specificity score and evidence reliability used in this project.
I performed a 10-point stress test using paired inputs from 00 to 99. The resulting confidence output form a linear curve where the output increases proportionally with the inputs. This linear behavior indicates that the fuzzy system is behaving similarly to a direct mathematical scaling rather than a non-linear fuzzy inference process. So, based on the linear output, I hypothesize that the system output is dominated by the firing string calculation rather than the membership function shapes. This suggests that change to individual membership function may have minimal impact on the final confidence output. So after modifying one membership function parameter and rerunning the same 10 inputs, the output curve remains unchanged. So this confirms that the system is insensitive to membership functions tuning under the current rule and firing design. This occurs because the firing strength is calculated directly from the CRIPS input values rather than from the membership degrees. So as a result, the membership function do not significantly influence the confidence output. So in the context of video manipulation detection, this linear behavior means that confidence increases at a constant rate with evidence quality. While this provides predictability, it limits the system's ability to model uncertainty and ambiguity, commonly present in forensic evidence. As a result, subtle change in mid-range evidence may not be emphasized, reducing the advantage of using fuzzy logic over traditional scoring methods.